What is electrical resistance and why does it matter? Have you ever wondered why some materials allow electricity to flow easily while others resist it? This brings us to the concept of electrical resistance. Electrical resistance is a property of a material or an electrical component that measures how much it opposes or slows down the flow of electric current. In simple terms, it is a force that makes it harder for electricity to move through a material. Resistance is measured in units called ohms, named after the German physicist Georg Simon Ohm. The higher the resistance, the more difficult it is for the current to pass through. This is important because it affects how electrical devices function. For example, when you plug in a toaster, the resistance of the wires and the heating element determines how much current flows and how hot the toaster gets. Different materials have different levels of resistance. Conductors like copper and aluminum have low resistance, allowing electricity to flow freely. Insulators like rubber and glass have high resistance, preventing current from passing through. This property is essential for safety. Insulators protect us from electric shocks by keeping the current contained within wires. Now, why does resistance matter? Understanding electrical resistance helps us design better electrical systems. For instance, in a circuit, if the resistance is too high, devices may not work properly or could overheat. Engineers must calculate resistance to ensure that circuits operate efficiently and safely. Moreover, resistance plays a role in energy consumption. When electricity flows through a resistor, some energy is lost as heat. This is known as resistive heating. For example, in electric heaters, this property is used intentionally to generate warmth. However, in other cases, like in power lines, this energy loss can be wasteful. In summary, electrical resistance is a fundamental concept in physics that affects how electricity behaves in various materials. It influences everything from the design of electrical devices to energy efficiency. Understanding this principle allows us to harness electricity effectively and safely in our daily lives.